This is the video introduction to understanding computer networks, part of the Communicating with Mars lesson plan. It was created by Jonathan Maple and edited and narrated by Sean Krupa. This video and accompanying lesson plan are part of Ohio University's Boat of Knowledge in the Science Classroom project, funded by the National Science Foundation. Before we go any further, let's review STEM. STEM stands for Science, Technology, Engineering, and Math, and all of the subjects covered in this lesson are STEM related. Let's talk about the basics of computer transmissions. We'll start with terrestrial transmissions, or, in other words, how computers talk to each other on Earth. These transmissions come in three forms: wired, wireless, and satellite. Eventually, we're going to send humans to Mars, and how we talk with those astronauts on Mars is going to be a big problem that we need to solve. Here are two main complications with communicating with Mars. The first is travel time. Even on Earth, I'm sure you're familiar with the fact that sending a simple phone text takes a couple of seconds. This time is represented by the signal transmitting from your phone to a satellite and to the person who you wish to send it to. However, the great distance between Earth and Mars sets the lower end of time it takes to send a message at 30 minutes. The next complication is disruption. What happens if the Earth loses sight of Mars, which is possible? Also, solar radiation can scramble a packet of information. We see this on Earth quite often. Here's why solar radiation matters. More solar radiation increases bounce in the ionosphere. This requires difference calculations to get radio signals out to satellites. Also, this can create interference outside of the atmosphere. And part of the issue with sending humans to Mars is the increased exposure to solar radiation. This can do harmful damage to our skin. So, can STEM offer a solution? Here are several suggestions. First is automation. The second is peer-to-peer networks. The third are ad hoc networks. This is where peers automatically connect and share information with each other. Let's explore this further. The plan to test ad hoc networks was called ZebraNet and was created by Princeton University. It was a joint project between the electrical engineering and biology departments. The original idea was to track GPS movements and data of wild zebras. The real-world experiment had limited resources, however. The GPSs required power, and there were no cell phone signals. The plan was to create an artificial network at a watering hole. Several major watering holes would get Wi-Fi trees, and 2.4-pound computers were strapped to the back of the zebras. When a zebra would be near, they would trade all their data with all the other zebras. In this way, a zebra traveling to the water hole would know all the information obtained by all the other zebras. So how does this help with communicating with Mars? Well, there are already satellites around Mars. Satellites could automatically send data when it sees a new node. This could be an additional satellite or a ship. And this propagates the network with data. In summary, in order for computers to talk, standard rules must be followed. Current computer science and new ideas will be needed if we ever hope to successfully communicate with the humans we wish to send to Mars. And Princeton's ZebraNet was a novel idea to help with this. This concludes the video introduction. Thanks for your attention.